So now the today's topic, the last topic of this chapter is transformer. Transformer. Okay, students. So you can write transformer is a device. Transformer is a device that is used to alter the voltage, to change to the voltage. It used to convert high voltage into low voltage and vice versa. This device called transformer. The AC is communicable because of transformer. The AC is communicable because of transformer. Now write principle of transformer. Principle. Transformer works. The transformer works on the principle of mutual induction, and we know that mutual induction means whenever we change the current through a coil, then the induced effect or current produced in the with one coil, then it induces the effect or induced EMF through the neighboring coil. This phenomena known as mutual induction. Transformer works on the principle of mutual induction. Okay. The principle of the transformer. Now the working construction of transformer. So transformer is a device that consists two coils. Okay. In this way, this device is transformer. This known as primary coil and this known as secondary coil. Okay, from the primary coil, we apply the input AC, and from the secondary coil, we receive the output. Here, let this one transformer that converting the high voltage into low voltage. Sorry, low voltage into high voltage. Low voltage AC into the high voltage AC. Okay. Acts in two ways. Transformer two ways. One is step up and second is step down. Okay. Step up act in this way. It converts low voltage AC into the high voltage AC, and the step down this convert step down transformer, it convert the high voltage AC into the low voltage AC. Okay, sir? This convert high voltage AC into the low voltage AC. So transformer is of two types: step up transformer and the step down transformer. Step up transformer convert, you can say step up transformer convert low voltage high current. Listen carefully, low voltage high current AC into the high voltage low current AC. On the other hand, the step down transformer convert the high voltage low current AC into the you can say low voltage and high current AC. Okay. So in this way transformer works. Now you can write these are the types of the transformer. Now you can write the working of transformer. Working of transformer. Okay. There are two coils, primary coil and secondary coil. Okay. As we know by Faraday's laws, E1 is equal to minus N1 d phi upon dt, and the change to the secondary coil E2 is equal to minus N2 d phi upon dt, where N1 and N2 are the number of turns through the primary coil and the secondary coil. Equation first, equation second. Equation first divided second divided by equation first. E2 upon E1 equal to minus N2 d phi upon dt upon minus N1 d phi upon dt. Okay. So this one cancel, minus minus. So E2 upon E1 equal to N2 upon N1. So this is N2 upon N1 known as transformation ratio. Step up transformer, the transformation ratio N2 upon N1 always greater than 1, and for the step down transformer N2 upon N1 is less than 1. Okay, you can note down this one. आपने कहा step up N2 upon N1 greater than 1, N2 greater than N1. It means step up transformer is a transformer in which secondary coil having more number of turns than primary coil. And for step down, N2 upon N1 less than 1, N2 less than N1. For example, इस टाइप से होगा primary coil, and this one secondary coil for the step up, and for step down, this one the primary coil, and this the secondary. Okay. So where the more the number of turns, higher the voltage. Step down करना है आपको, तो less number of turns through the secondary coil. Secondary coil means through which we receive the output. Secondary coil means through which we receive the output. देखिए power Sir, whenever the AC flows through the wires, so it having voltage as well as current, both are there. Whenever AC flows through the wire, it having voltage as well as the current. And power P equal to VI remain constant. Power P equal to VI that remain constant. In case of step up transformer, step up, when we increase the voltage, let P dash, V dash and I dash. If V dash greater than V for step up transformer, dash means voltage change 1, then I dash less than I. Overall power remain constant. Overall power remain constant. You can say, for example, for step up transformer, the input power P equal to VI, let input power P equal to VI, and then the output, let V dash equal to V dash into I dash. And we know the step up transformer step up the voltage. So let V dash equal to n times of V. It increases the voltage in n times. Then I dash decreases in the same ratio 1 upon n times. If voltage increases by n times, then current reduces by 1 upon n times. Then the entire power P dash equal to V dash, I dash, V dash, n time of V, I dash is 1 upon n times of I. And cancel. So P dash equal to VI equal to P. Okay. So in this way, overall power remain constant. We can say if voltage increases, then current reduces. Okay. So overall we can say the power input is equal to power output. Let for primary coil power P1 V2 V2 I2. So from here we can say V2 upon V1 is equal to I1 upon I2. You can say power in terms of EMF E. So E2 upon E1 equal to I1 upon I2. And we know that this value also, and we know that E2 upon E1 is equal to transformation ratio N2 upon N1. So इसको आप first मान लीजिए, first one को, and this one second. So by these two equations, जो भी number होगा whatever, so by these equation we can say from equation first and second we can say E2 upon E1 is equal to N2 upon N1 is equal to I1 upon I2. It means transformation ratio in the reverse manner of the current is in the reverse manner of the current. Now write the efficiency of transformer. Sir, efficiency for any system is given as what is the output at the cost of input. It is denoted by eta, efficiency, eta in percentage. Efficiency given percentage, that is given as output power upon input power into 100. This is called efficiency of transformer. Okay. Sir, with respect to input, some power, a small amount of power get reduced. So that why efficiency never not equal to the 100%, but not less than it, about in between 95% to 99%. In between the 95% to 99%. Causes of power loss. Why the efficiency not equal to 100%? Why the efficiency is not equal to 100%? Why it is between 95 to 99%? Because there are some reasons, some causes due to which power loss takes place. Okay. Down, there are the following power losses. There are the following power losses of transformer. Very first is known as copper loss. You can note down this one. Very first loss is copper loss. As the primary and secondary coils of transformers having the copper winding, so when the AC flows through the copper winding, some energy get lost in form of heat. Okay, some energy get lost in form of heat. So that energy you can say in terms of power loss. And we have not only we have to give the energy loss, we have to give the possible correction also. So this loss of energy can be minimized by using the thick copper wire. Thick copper wire having lesser the resistance. The thick copper wire we know are proportional to 1 upon 8. For thick copper wire having the less the resistance, so power loss be equal to I square R. So due to less resistance, it shows the less power loss. So very first is copper loss. The primary and secondary coils are made up of copper wire, and due to the flow of AC through the copper wire, some energy get lost in form of heat, and this power loss can be minimized by using thick copper wires. Okay, this first is copper loss. Second is you can write the eddy current loss. Second, you can write the eddy current loss. Okay, in the eddy current loss, when the AC flows through the coil, then it produces the eddy current. When flux changes through the metallic piece in form of whirls, it produces the eddy current. So to minimize the eddy current, we use the laminated soft iron core. Okay, central core is of iron core. Over the there, so that iron core used soft iron laminated iron core to avoid the eddy current. We can reduce the eddy loss. And the third, the transformer loss, that is known as hysteresis loss. Hysteresis loss. I explained you the topic hysteresis. When the AC flows through the primary and secondary coil, so due to one complete cycle, AC having one positive, one negative cycle, so in one complete cycle, the coil gets magnetized and demagnetized. So it forms a hysteresis loop, and the area of loop gives the energy loss. In the hysteresis loop, when the AC flows through the coil, then for first positive and second negative half cycle, it get magnetized and demagnetized. So in this way, it form a hysteresis loop, and we know that the area of this hysteresis loop gives the energy loss. Gives the energy loss. So to minimize it, we choose the core of such material that having lesser the hysteresis loop area. For this purpose, we use the soft iron. Soft iron having lesser the hysteresis loop area as compared to steel. Steel having higher the hysteresis loop area as compared to the soft iron. Okay. So this one the energy loss. Next one you can use the flux leakage. The next energy loss due to of transformer, that is flux leakage. Okay. When the flux from primary coil induces over the secondary coil, then on the way some flux get leak out. Some flux can leak out. मान लो एक ग्लास से आपने दूसरे ग्लास में पानी डाला तो क्या आपने एक आध बूंद पानी बाहर गिर गया. Okay, so when the flux transfers from one coil to another, then in between the way, on the way, some flux gets leak out, so this losses the energy. Now this we can minimize by winding primary and secondary coil over the same limb. दोनों का आप एक ही limb पे wind कर दीजिए, तो जो प्राइमरी वही सेकेंडरी कॉइल, तो पावर लॉस नहीं होगा ड्यू टू द फ्लक्स लीकेज. Okay, so in this way, then the one more you can write the humming sound. Humming sound, as the transformer works, AC flows through the coil, then for one cycle of AC, the core of the transformer feels the contraction and expansion. मतलब जो होता है, because of that वो थोड़ा सा हल्का contract then expand. This phenomena known as magnetostriction. This phenomena is known as magnetostriction. Okay, so because of compress, extend, little bit, very minute, it produces it generates some frequency, and corresponding to that frequency there is some sound that called humming sound. अगर आप ट्रांसफार्मर के पास से गुजरेंगे इस टाइप से आपको एक साउंड मिलेगा, that is humming sound. No way that we can minimize it. So this is called humming. You can say power losses of transformer. So in this way we have finished this chapter, that AC. One topic is given, AC generator, that we have studied in that chapter. The chapter is electromagnetic induction. There we have studied the AC generator. Okay. Main topic is